Hey class, I'm Mr Thornton, and I'm going to help you succeed in your GCSE. This lesson, isotopes. This topic was requested by Unknown UKB, Sally John and Rachel Elvin. Thanks guys. If you've got a topic which you'd like me to cover, then just leave a comment below. Here's the periodic table entry for hydrogen. You can see that both the mass number and the proton number are 1. Now what this tells us is that there is 1 proton in the nucleus, because the proton number is 1. It tells us that there's 1 electron around that nucleus, because there's always the same number of electrons as there are protons. And because the mass number is 1, then we know that there is only one thing in the nucleus. Well, we've already decided that there's 1 proton there, so there can't be anything else. So, this is a hydrogen atom. If you need a refresher on how to interpret the periodic table, then please check my other video just here, and that'll run you through making sense of all of those numbers. But it's pretty straightforward. So, our basic hydrogen atom has just got 1 proton in its nucleus and 1 electron round the outside. And almost all hydrogen atoms in the world and in the universe are exactly like this. However, there are a few hydrogen atoms which are a tiny little bit different. And so these different types of hydrogen atoms, we refer to them as different isotopes. This one is the most abundant isotope. It's almost 100% of all those hydrogen atoms, but there are a few other isotopes out there. Occasionally, a hydrogen atom will have a neutron in its nucleus. And so its symbol is this. We call this hydrogen 2 because its mass number is 2. Now, chemically, it's exactly the same as hydrogen. It reacts with things in exactly the same way. It's got 1 electron in its outer shell because it's got 1 proton in the nucleus. And that 1 electron bonds to things in exactly the same way as a normal hydrogen atom would. And so you can still form compounds like methane and water with this type of hydrogen atom. The only difference is a physical difference, that it's just a little bit heavier. In fact, it's twice as heavy. Our 2 different types of hydrogen here are both isotopes of hydrogen. The periodic table tends to list the most common isotopes, but there are other ones as well. This is about 0.015% of all the hydrogen atoms out there. And it's actually got a special name. We call this deuterium. But it's just hydrogen 2. That is hydrogen with a mass number of 2. Which means there's 2 things in the nucleus. We know one of them's a proton, and so the other one's got to be a neutron. This isn't the only isotope of hydrogen either. You can also have hydrogen 3. This is hydrogen with a mass number of 3, still just got 1 proton, still just got 1 electron going round the nucleus, and so those 3 mass units, if only one of them is a proton, then the other 2 have got to be neutrons. And that's exactly what we get. So there are 3 key isotopes of hydrogen here. The first one is normal hydrogen, or hydrogen 1. The second one we call deuterium, or hydrogen 2. And this third one we call tritium. This is hydrogen 3. All of them react in the same way. All of them form compounds in the same way. So a water molecule made from these second 2 types of hydrogen will be a little bit heavier. It will still be water. It will still look and feel and taste like water, but it's got to weigh a little bit more than normal water made with a normal hydrogen atom. Quite often these isotopes are radioactive. Deuterium isn't, but tritium, that's hydrogen 3, is. And so if you were to drink water that was made with tritium rather than hydrogen 1, then that would be radioactive, and it would be a bit of a problem. In fact, as a side note, the recommended medical treatment if you have drunk a load of tritium water is to drink 12 pints of beer to try and flush all that water out of your system. It's probably the only time when a medic would actually recommend you drink a large amount of beer. Aside from hydrogen, we don't tend to give special names to different isotopes. So, for example, carbon. The most common isotope of carbon, the one in the periodic table, is this one, carbon-12. The mass number of 12 and the proton number of 6 tells us that we've got 6 neutrons in the nucleus. So most carbon atoms are like this one. However, there is another relatively common isotope of carbon which we quite often use, and that's this one, carbon-14. Again, it's got 6 protons, it's got 6 electrons, it reacts in exactly the same way as carbon, but it's got a slightly different mass. It's a little bit heavier. If we take the number of protons away from the mass number, we can figure out how many neutrons there are. And in this case, as I'm sure you've already worked out, there are 8 neutrons. This type of carbon is present in all living things in very small amounts, and it is ever so slightly radioactive. It decays over the course of thousands of years. And if we use what we already know about half-life, please do check this video if you're not sure about that. But if we use the half-life, we can figure out how long it is since an object which was once living has died. This is known as carbon-14 dating, or radiocarbon dating, or sometimes just carbon dating. So long as it's something which used to be taking in carbon atoms, which all living things do, then we can figure out how long it is since it stopped taking in those carbon atoms. That is, how long since it died. That's all that you need to be able to do with isotopes. Figure out how many neutrons there are, and be aware that the most common ones are listed in the periodic table, but that there are other ones out there, and there are just different numbers of neutrons in the nucleus. Sometimes there's more, sometimes there's less. Another example is uranium. The most common form of uranium is uranium-238. But the type of uranium which we want to use in nuclear reactors is uranium-235. Its mass number is 3 less, but it must have the same number of protons, and so we can assume that it's just got 3 less neutrons. So without even seeing the proton number, we can figure out what the difference is between 2 isotopes. It's always just a different number of neutrons. I'll cover applications of radioisotopes, that is radioactive isotopes, in a future lesson when I look at applications of radioactivity. But for now, when it comes to isotopes for both chemistry and physics, that's all you really need to know. Just remember, your periodic table lists the most common isotope of each element, but there are others out there with different numbers of neutrons in the nucleus, and that's the only difference between them. I hope that video really helped you. To see what else I can help you with, there's lots more videos to check out on my channel. Scroll down the main page there to see I've already sorted them into playlists to help you find the video you need. You can also check out my revision guides, which cover everything you need to know for the exam. They feature links to my videos, revision tips, cover both foundation and higher tier, and unlike a lot of revision guides, they also point out what you don't need to waste time learning. If you want to check your learning, try the SnapQuiz website and app, which allow you to identify which areas you need to spend the most time learning. Remember, this is the only YouTube channel which brings you the teachers, the textbooks, and the tests all on your terms, on mobile phone, tablet, or computer for you to revise when you want and how you want, even immediately before you go into the exam. All of these links and any others for this video will be down in the description. Lastly, it really does help my channel if you want to leave likes, if you subscribe, or if you know someone else who's having trouble, tell them to search for Mr Thornton. Good luck in your GCSEs everyone, and thanks very much for watching.